Hey students, today's lesson is on rewriting equations and formulas. So to start with, let's go ahead and look at a key idea. A literal equation is an equation that has two or more variables. So go ahead and get that definition down. A literal equation is an equation that has two or more variables. And if we're going to rewrite a literal equation, that just means we're going to solve for one variable in terms of the other variable. So that if we know one of the variables, we can figure out what the other one is. So go ahead and pause and get those written down if you don't have them yet. Let's go ahead and look at an example here. So here we have the equation 2y plus 5x equals 6. And we're going to solve this for y. So we're not going to know what x or y is equal to, but we're going to have a y equals something, and there will be x in that something. Okay, so we're going to get the y isolated all the way by itself. So I'm going to start by rewriting this equation. So if I want the y isolated by itself, my first step is going to be to subtract the 5x. So I'm left with 2y equals, you usually see a variable term written first, so I'm going to say negative 5x plus 6. All right, now to get y by itself, I need to divide this side by 2 and this side by 2. So y equals, I can simplify this by dividing each term by 2. Negative 5x over 2, I can just say negative 5 halves x or negative 2.5x. I'm okay either way. And then 6 divided by 2 is 3. So negative 5 halves x plus 3. Here's example 2. So we're going to rewrite this formula. We're told that the formula for the surface area of a cone is S, or the surface area, equals pi r squared plus pi r L, where L is the slant height of the cone. So if you have a cone like this, it's this slant height right in here. Not a very nice cone. There we go. Okay, so let's go ahead and write our formula, and then we're going to try to solve for L. S equals pi r squared plus pi r L. Okay, so my first thing is going to be to subtract pi r squared from both sides. So on the left side of the equation, I now have S minus pi r squared, and that's equal to pi r L. So now, to solve for L, I need to divide both sides by pi r. Oops, I wrote pi to the rth power. Whoops. All right, pi r. So on the right side of the equation, that's going to all cancel out, and we're left with L. On the right side of the equation, I'm going to end up writing S over pi r minus pi r squared divided by pi r is just r, right? R squared divided by r is r, and pi divided by pi is 1. So L equals S over pi r minus r. Okay, so a key idea here. A formula for converting from degrees Fahrenheit, or F, to degrees Celsius, or C, is C, Celsius temperature, equals 5/9 times whatever the Fahrenheit temperature is minus 32. So that's just a common conversion that people use if they're trying to convert between Fahrenheit and Celsius. But in this case, this is easy to convert from degrees Fahrenheit to degrees Celsius. We can rewrite this so that it's easier to convert the other direction. So we're going to solve this formula for F. We're going to isolate the F. So in this case, the first thing we want to do is multiply by 9 over 5. We know that 5/9 times 9/5 is 1. So that leaves us with F minus 32 on the right and 9/5 C on the left. Now we're going to add 32 to both sides. And we have F equals 9/5 C plus 32. Okay? So here's an application. We want to know which has the greater temperature. Lightning at 30,000 degrees Celsius or the sun at 11,000 degrees Fahrenheit. So we can go either way. We can take the lightning and convert it to Fahrenheit, or we can take the sun and convert it to Celsius. Either way, we should be able to compare. So let's go ahead and look back at our original formula here. C equals 5/9 times F minus 32. Let's start there. C equals 5/9 times F minus 32. So let's go ahead and use that to convert the temperature of the sun to Celsius. So if the sun is 11,000 degrees Fahrenheit, we're going to say C equals 5/9 times 11,000 minus 32. All right, we're probably going to need a calculator for this one. Go ahead and see if you can work this out, the calculations. I'm going to grab my calculator. So this is C equals 5/9 times 10,968. Then we can multiply it times 5/9. And we get 6,093 1/3. And that would be in degrees Celsius. So if we're comparing the sun to lightning, the sun is actually quite a bit cooler than lightning. Lightning has a temperature of 30,000 degrees Celsius, and the sun is only 6,093 1/3 degrees Celsius. All right, so go ahead and try a few on your own, and I will see you soon.